A circle of radius length root 20 contains a point -1, 3. Its centre lies on the line x plus y is equal to 0. Find the equations of the two circles that satisfy these conditions. So what we're going to do is let the equation of such a circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So this is our second general equation of a circle. So this is given to us in our formula book. So we know that the radius length is root 20, that was told to us in the question. So we're going to let square root g squared plus f squared minus c equal 20. And then we're going to square both sides to get rid of the roots. So we end up with g squared plus f squared minus c is equal to 20. Now we know that the point -1, 3 belongs to the circle that was told to us in the question. So we're going to substitute into our equation, our formula at the top, -1 in place of all the x's and 3 in place of all the y's. So this x squared becomes -1 squared, this y squared becomes 3 squared, 2gx becomes 2g times -1, 2fy becomes 2f times 3. We bring down the plus c and that's still equal to 0. We multiply this out, -1 squared is 1, 3 squared is 9, minus 2g by -1 is minus 2g, 2f by 3 is 6f, bring down the plus c and the equals 0. Then we simplify, bring down the minus 2g, bring down the 6f, and then 1 plus 9 is going to be 10, and we're going to bring that over the other side of the equal sign, so we get minus 10, and then we bring down the plus c. So we end up with minus 2g plus 6f plus c is equal to minus 10. Now we know that the centre of our circle lies on the line x plus y is equal to 0. And for the moment, we're going to let our centre be minus g minus f. So minus g minus f belongs to x plus y is equal to 0. So we're going to swap the x for minus g and the y for minus f. So we get minus g plus minus f is equal to 0, which gives us minus g minus f is equal to 0, which gives us f is equal to minus g. So now we have three equations, 1, 2, and 3. So we're going to take our second equation, which is minus 2g plus 6f plus c is equal to minus 10. And we're going to take our third equation, which is f is equal to minus g. And we're going to substitute f is equal to minus 3 into our second equation. So we're going to swap that f for minus g. So we end up with minus 2g plus 6 times minus g plus c is equal to minus 10. Then we're going to simplify, bring down the minus 2g. 6 times minus g is minus 6g. Bring down the plus c and bring down the equals and the minus 10. Then we simplify again. Minus 2g minus 6g is minus 8g. So we're going to bring that over the equal sign. So it becomes plus 8g. And we still have minus 10. So we have c equal to 8g minus 10. So the idea here was to take two of our equations, substitute the simpler one into the more complicated one, and simplify so that we are reducing our number of variables. So we end up with c equal to something, and it's containing one of the variables. Then we take our final equation, which was actually the first one that we worked out, which was g squared plus f squared minus c is equal to 20. Next, we're going to swap the f for minus g, because remember we got f to equal minus g, and we're going to swap the c for 8g minus 10, because we got c to equal 8g minus 10. Next, we simplify. So we have g squared equals plus g squared minus 8g minus 10 is equal to 20. So minus g squared gives us g squared, and minus g squared plus g squared gives us 2g squared. So g squared plus g squared gives us 2g squared. Minus by 8g is minus 8g, and minus by minus 10 is plus 10, and that's all equal to 20. We bring the 20 over the equal sign, becomes minus 20, and plus 10 minus 20 is minus 10. So we have 2g squared minus 8g minus 10 is equal to 0. We're going to divide across by 2 to simplify, so we get g squared minus 4g minus 5 is equal to 0. We factorize to get g plus 1 times g minus 5. We let each of our sets of brackets equal to 0. and we solve. So we get g is equal to minus 1 and g is equal to 5. Now we have two g values. Now we just have to work out our other variables. So case 1, if g is equal to minus 1, then f, which is equal to minus g, will be equal to minus minus 1, which is 1. So f would be equal to 1. And c, which is equal to 8g minus 10, will become minus 8 minus 10, because remember g is minus 1, and minus 8, and 8 times minus 1 is minus 8, and minus 8 minus 10 is minus 18. So c is equal to minus 18. So we take our g value, our f value, and our c value, and we substitute it into the general equation, which is up here. So we end up with x squared plus y squared minus 2x plus 2y minus 18 is equal to 0. So this is one option for a circle. Case 2, if g was 5, we would have g is equal to 5. Then f would be equal to minus 5, because remember f was equal to minus g. And c would be equal to 40 minus 10, because remember c is 8g minus 10. So it would be 8 multiplied by 5 minus the 10. So that would be 40 minus 10, which is 30. So then we would take our g, our f, and our c values and substitute it again into the general equation. And we would end up with x squared plus y squared plus 10x minus 10y plus 30 is equal to 0. So now we have our two equations of the circle. So there's no set way in which you have to do this. You're going to form three equations. You should ideally take the simpler one, which is obviously going to be f equals minus g, and substitute it into the next simpler one, which doesn't have any squares in it. And then simplify again and substitute into the most complicated one, which has the squares in it. But the whole idea here is that you are reducing your variables each time so that you end up with one variable, or in this case, one set of variables. So you have two g values. And you take that value and you substitute it into the other equations to find your other values.